Next, let's dive into Amazon's SageMaker. SageMaker is a component of Amazon Web Services and allows you to create notebooks hosted on AWS that can train large-scale models in the cloud and then vend predictions from that model from the cloud as well. It's an easy way to get some serious computing horsepower behind your machine learning system in an on-demand manner. We're starting to see this on the exam as it scales better than Amazon's ML service, and it has more flexibility and more advanced and modern algorithms, although it's definitely not as easy to use as Amazon's ML service. You're going to have to write Python code in what's called a Jupyter Notebook in order to use SageMaker. But it's still fully managed, so at least you don't have to worry about provisioning capacity for your machine learning jobs like you would with Apache Spark or something, no matter how complex or advanced they might be. SageMaker includes 3 modules that you have to work through: build, train, and deploy. So the build module provides a hosted environment for working with your data, experimenting with algorithms, and visualizing your output. This is where you're going to be working with fully managed instances running Jupyter Notebooks for training, data exploration, and pre-processing. Now, these Jupyter Notebooks that you're going to be writing your Python code in to build your model are preloaded with some pretty cool stuff, such as CUDA and cuDNN drivers for deep learning. These are drivers that allow you to use the GPU on the computers in your cluster to accelerate your neural networks. It also includes a wide variety of Anaconda packages, which are data science related and machine learning related packages for Python. And it also has libraries available for TensorFlow, Apache MXNet, PyTorch, and Chainer. So a very powerful tool set for not just machine learning in general, but also for deep learning and doing deep learning at large scale. So at a high level, it provides high-performance, scalable machine learning algorithms optimized for speed, scale, and accuracy. SageMaker in the build stage also has available built-in, fully managed reinforcement learning algorithms, which is another branch of machine learning, including some of the newest and best-performing reinforcement learning algorithms in the academic literature today. It offers broad framework support, so you can actually test and prototype your SageMaker models locally if you want to. You can download a Docker container to your local environment and work with that to actually develop your modules for SageMaker, and you can test them actually as well using the SageMaker Python SDK without actually being online. Once you've built your model, which you have to know what you're doing definitely to get to this point, you would then go to the training stage. So the train module allows for one-click model training and tuning at high scale and low cost. There's also something called SageMaker Search, which allows you to quickly find and evaluate the most relevant model training runs from potentially hundreds and thousands of your Amazon SageMaker model training jobs. So remember, you might want to train your model in several different ways using several different data sets and several different hyperparameters, for example. So training is not usually a one-stop thing. You're going to train it many, many times. Finally, once you've settled on your trained model that you want to work with, you will deploy that to the cloud and actually make predictions using it. So the deploy module provides a managed environment for you to easily host and test your models that will make predictions securely and with low latency. There's a batch transform mode that allows you to run predictions on large or small batch data. And again, this is all fully managed, so SageMaker will manage your production compute infrastructure on your behalf to perform health checks, apply security patches, and apply all the other routine maintenance that you need. And this is all with built-in Amazon CloudWatch monitoring and logging as well. But you don't have to worry about it, it is fully managed. SageMaker enables you to deploy inference pipelines, so you can pass raw input data and execute pre-processing, predictions, and post-processing on real-time and batch inference requests as well. There's also a new feature called SageMaker Neo that allows machine learning models to be trained once and run anywhere in the cloud and at the edge. So you can actually push out your prediction models out to edge nodes and make them really, really fast if you have some sort of external application deployed on the internet that needs to get predictions back from a model at very low latencies. All of that is a very fancy way of saying that SageMaker is very powerful, and compared to Amazon's machine learning service, its older service, it kind of leaves it in the dust. Granted, it takes a lot more work and you really have to know what you're doing to use SageMaker, but it really unleashes an amazing amount of power, and it's all still fully managed and runs in the cloud. So it's pretty interesting stuff. Again, it has the entire power of TensorFlow and MXNet available to you, and GPU accelerated deep learning. Together, this means that you can really build very advanced artificial intelligence systems that are trained on massive data sets and can very quickly make predictions in much the same way that your brain does. The scaling of SageMaker is effectively unlimited. I mean, if you want to go build a human brain, here you go, have at it. And also, interestingly, it has hyperparameter tuning jobs, so you don't have to do all the dirty work of trying to find the right hyperparameters for the models that you build. You can actually have SageMaker go off and use all the power of the cloud to run a bunch of tests on different parameters and automatically converge on the hyperparameters that provide the best accuracy for the model that you're trying to build. If you want a little sneak peek of what it is you're getting yourself into with SageMaker, here's a snapshot of just a small piece of a Jupyter Notebook that I was using when working with SageMaker myself. This is just a small piece of data that was testing a model that I built to actually predict movie ratings for people based on the movie ratings of known people. It's really not for the faint of heart. You need to be very comfortable with Python to use SageMaker, and your hosted notebook will let you do everything you need to do, but you need to prepare all of your data. You're going to have to convert it to a protobuf format, which SageMaker specifically requires. You're going to have to build your model here. You're going to have to tune your hyperparameters here, deploy your model, and make predictions from it, all using Python. So you've got to know what you're doing to use SageMaker, guys. I mean, there are some ways of using the console to do some of this stuff, but it's really meant for machine learning researchers who know what they're doing and they know what they're doing with Python. However, it is super, super powerful. Let's talk a little bit about security with SageMaker. They have put a lot of thought into SageMaker in general, and that extends to security as well. So your code itself will be stored in ML storage volumes, and these will be controlled by security groups, and you can optionally encrypt them at rest. So if you even want your code to be safe and secure from prying eyes, and you want to keep that proprietary, that code can be kept secure. Any artifacts that are being sent around throughout the cluster, well, it's fully managed, so you don't really think about the cluster, but within the cloud, all that stuff is encrypted both in transit and at rest automatically. The API and console access is all secured by SSL. It also integrates with IAM roles, so you can control what services SageMaker can talk to, and it can work with encrypted S3 buckets if your source training data is also secure and sensitive as well. Furthermore, it integrates with KMS, the key management service for SageMaker notebooks, training jobs, and endpoints for even further security. From an operations standpoint, Amazon SageMaker can integrate with Amazon CloudWatch and Amazon CloudTrail. CloudWatch is used to monitor Amazon SageMaker, which collects all the raw data and processes it into readable, near real-time metrics. CloudTrail records the history of your Amazon SageMaker API calls that were made on your account if you need sort of a record of everything that you've done with it in the past. So that's SageMaker in a nutshell. That's all you need to know about it in the context of the exam. Basically, it's a very powerful machine learning framework. It is fully managed, highly secure, very powerful, and appropriate for deep learning and massive data sets that is not limited by the 100 gigabyte limit of Amazon's machine learning service.